might start with is just quickly run this Kickstarter video. Does this have audio?
It should have. If you just play anything with sound on it, there is a remote control somewhere.
What if your smartphone could stay ahead of the pack? What if you could add additional features that you never thought would be possible on your mobile device?
Hi guys, my name is Alex. I'm co-founder of nexpaq, a modular phone case that will change your life.
Nexpaq is a modular smartphone case that allows you to customize your phone to do more and to allow you to do more with your phone. How does it work? Slide your phone into the nexpaq case, add some modules, access the app, and enjoy the unique features each module provides. We've already created 12 modules to get you going, and there's more to come. nexpaq is the first phone case that allows you to switch hardware between Android and Apple devices. This means you can trade modules with friends and family and experience the different features each module provides. If you do choose to upgrade your phone, all you'll need to do is change your case and your modules will always work with you.
From the first idea, it took us about 2 years to arrive where we are now.
We were originally inspired by brainstorming cases that allowed you to add one new feature to your phone, and we thought, why not make one case that allows for many features that you can customize for your lifestyle? We have an experienced team with members spread across the world, all bonded together through our passion for nexpaq. We've been working around the clock to collaborate on each other's time zones and get our device to where it is today. What comes out of this campaign is just the beginning. We are currently working on additional modules for the near future, but even more importantly, we are building a community for developers to thrive and meet the needs and wants of nexpaq users. Think about an app store for modules that can enhance your phone. Whenever we show it to someone, we get some crazy ideas for future modules.
What about a tiny lip gloss? Or a little blush?
Night vision camera,
3D camera? Walkie-talkies to talk with your friends?
pillbox,
A fingerprint scanner?
a game controller.
A baby monitor? A lie detector for my boyfriend?
You see, this really is just the beginning. We need your help to fund nexpaq to bring it to you.
But more importantly, we need your ideas to carve the future of nexpaq.
So if you're as excited about nexpaq as we are, pledge today.
Pledge today.
So I'd like to do an overview of what most people see nexpaq as, but it's actually much deeper than that, and it's very difficult for us to communicate, and we have this problem when we look talking to investors, to communicate the vision of nexpaq beyond just a modular phone case. So this will be my attempt at doing that. Essentially what we want to do is turn the statement that hardware is hard, which is universally known, to hardware is easy. What's the hardware problem? Can anyone give me a few issues? What's the barrier to entry to hardware?
Design.
Design?
Yeah.
I mean, what's specifically about design?
The electronics design. So going from something on a breadboard to something that you can fabricate for production.
Yes, yes.
Yeah.
Anything else in terms of, if you have a design, what's the next step? How do you turn, compare it to software, what's the difference?
Well, once you're committed.
Anyone can make software. If you've got a computer, you can write software.
Correct.
Yeah.
I think the software is a lot easier than the distribution of hardware. So, nexpaq, we see there's two problems with hardware. One, the consumer side, which is, this is the IoT sphere. There's more and more incompatible connected gadgets being released to market. And they're all doing different things, but they all can't talk to each other. So you end up in your handbag or in your pocket having more and more devices. Consumer side. The developer side is, a hardware supply chain is always high cost, complex and high risk. There's nothing you can do about that in terms of, you always have to do product release processes, you need to do compliance, you need to do manufacturing tooling, you need to do inventory, then you need to do distribution, then you need to do retail. Unlike software where if your product works, you have the software distribution channels ready for you, such as the App Store. So our solution to this is to standardize hardware modules plugged into a modular phone case. This is sold as a consumer side, and our supply side is an ecosystem where it is easier to develop a module than it is to work with Arduino, and also manufacturing and distribution partners that drastically lower the costs associated with traditional supply chains. So our manufacturing partners and our distribution partners are geared, ready to go to supply these sorts of modules in these sorts of form factors. Nexpaq is the hardware app store. So if you look at the software side, 10 years ago, the only interesting app on your Nokia 3310 was Snake. Now, anyone, as you said, can create a function feature-rich app and sell it to an audience of billions through App Store and Google Play. So we call this democratization of the software industry. It was moved away from software studios and software companies. 10 years ago, everyone thought, I need to join a company to be able to publish a title. Now, if you have a good idea, you can possibly do it at home. Now, not many software developers are particularly successful doing this, but it's that golden egg that they're after that drives this whole industry forward. We want to do the same thing only for hardware. Now we start this democratization process by piggybacking on the largest infrastructure ever, which is smartphones. Everyone's got one. The fastest growing tech companies today have always piggybacked off pre-existing networks, and we want to do the same, but via the smartphone by creating a smartphone case. So this is the start of our democratization journey. The trouble is, everyone starts thinking about us as a smartphone case manufacturer, and that's not the message we want to get to. That's only just a start. That's our market entry strategy. Our vision is that we have a set of gateways. Our open platform can create many different gateways to accept these standardized modules. So you start from the smartphones, you move into home automation, and then you get into wearables, smart cities, smart transport type applications. All within the nexpaq ecosystem, all using the same nexpaq modules. 2 months ago, so we've been working on nexpaq for the last 2 years. We've raised about $1.5 million in funding, US. We did our Kickstarter launch 1st of May, which got a fairly good reception. We actually, in fact, only use Kickstarter really as a channel to market, as a marketing outlet. We've done several conferences, TechCrunch in New York, Maker Faire in Bay Area, Helsinki, and the Connect conference in Paris, and we've got a lot coming up. The sort of social media storm is doing quite well. Several million video views, lots of comments and likes. We've been published over 200 times in different global press outlets through influential tech blogs. So if you haven't seen much of nexpaq, then you're obviously not looking at any of these magazines or anything like that. Probably doing all the work. A lot of people also compare us to Google Ara, which do you guys know Google Ara? Yeah, so I'll address that point shortly. Number one point. The business model for nexpaq is also very unique, and now we're starting getting into the deep end nexpaq. So clearly the hardware app store is facilitating the sale of gateways, cases, and modules. That's the obvious one. The less obvious one is the software app side. Each module can potentially spawn many software apps. Then when you combine it with the data that you're collecting, these two really sort of take the business to the next level. And it's in this area where we really see the growth of the business. So obviously sensors collect valuable information for yourself, your Fitbit, your Pebble, your Apple Watch. You use them to sort of enhance your lifestyle. But the information that you collect is also valuable to a lot of other people. The only issue is that you don't know how to get this information out. One, do you want other people to see the information? And two, if you do, how do you get it to them and how do you monetize that? And this is what we're trying to achieve. So essentially, with our open platform, all the data from our various sensors belongs to our nexpaq users, but they can choose to opt in to say, hey, I'm happy for my data to be published to the market. And via the market, then we essentially broker the buyers, which are researchers, urban planners, government institutions, and so forth. A really interesting example is air pollution, which is a major problem in China and the Asian region. One of our first sensors that we've developed in-house was the air pollution sensor. Now this is useful for Chinese people living in China because they're constantly measuring air pollution to see, well, is it safe for me to stand here for an extended period of time? Is it safe for my child? Is it safe in the school environment? Now this information, the government of Guangzhou, which is near where we are, have already expressed keen interest in buying this information. If there's mass market uptake of this air pollution sensor, then all this data is extremely valuable to that government office. You can see a very granular idea of what air pollution is in their city. Now, again, we don't say we own this air pollution data. It's the buyer of the sensor that owns that data. they just say, well, I'm happy to earn a little bit of money by publishing it to the market. And government can buy that information. Now again, it's a free-floating idea, so it's a free-floating market idea. So you're what gets traded today? Like buying and selling, what's the most fluid type of investments? Anyone?
Like shares and
Correct?
currency.
Right,
gold,
right.
yeah.
Commodities, shares, currency, that sort of stuff. In the future, information is going to be power. So what we're trying to do is create the data market, a free-floating market. If I was a resident in Guangzhou, I can't ask for much of my data because there's probably 100 other people standing next to me with the same sort of information. But if I was in the Tibetan mountains, no one's going to go up there and put a sensor there. So I can demand more for my information. Going back to the previous slide of and there's a lot of guys that are coming up with very, very creative solutions on the software side. Again, let's take air pollution again. Useful for you if you're taking a reading and seeing what the air pollution is, but also if you're connected to this cloud network, a mother with a 2-year-old in a pram can get an alert to say, hey, move 50 meters that way, there's fresher air there. Now that might seem a bit silly where we are in Australia, but it's extremely valuable overseas in heavily polluted countries. So who knows about pollution in China?
How bad it is, or
How bad it is. So there's a measure called PM2.5, which is essentially particle size. That's the really bad stuff that gets in everywhere. It's really small stuff. Now, the World Health Organization says that on their scale, 7 is the highest that you can get to. Anything above 7 is uninhabitable for humans. An average day in China, in a very, very polluted city in China, in Beijing, is 100. That's just absolutely ridiculous. Last year, there was a policy where children couldn't go out to play in the yard if the reading was anywhere above 50. Last year, they went up 3 times. That's how bad it is. The urbanization rate is really driving this. There's 1 million Chinese moving to cities every month. That's 1 million people moving from country to city every month, all buying their first TV sets, all buying cars and so forth. So this is why this sort of what we call social data is extremely valuable to help countries like China grow, and of course us to innovate. Why us? So how do we kickstart the developer community? Because clearly a platform plays only successful if people are on it. This is a blood sugar gadget. It costs $70 to buy. It's got a housing screen, buttons, audio. But all you really need is this 50-cent sensor to measure the sugar content in the blood. Put into a standardized housing, standardized circuit designs, and all of a sudden you've got a $10 module rather than a $70 gadget. And you leverage the entire processing power that's in your phone. You leverage the fact that it's got a screen, it's got buttons, it's got audio. You don't need this separate device. Also, sorry, there's spelled glucose wrong, but there's the fact that your data is on your phone. It also means that it's accessible like cloud and interoperable with other systems. Let's look at another example. Google Nest. It costs $500 to install in a fixed location, a thermostat, a CO detector, and a camera. Does anyone have Nest?
not available here.
Oh, okay.
Yeah.
Okay. Well, that answers my question. They're generally not doing very well anyway, because I think Google sort of went into this IoT business a little bit early when it all was very new and sexy, and they paid like $3 billion for this thermostat, which is absolutely ridiculous in my mind. With a wall pack or a nexpaq gateway plugged into any Powerwall socket, we provide all 3 functions for under 130 US. And it's completely portable and modular, so you can move it from room to room. You can take the modules out and put them on the backside of your phone. So Google Ara being the competition. So what makes us different to Google Ara? Google Ara is a modular phone. And they haven't hit market yet, and if they do, they're going head to head with the likes of Apple, Samsung, and all the major phone manufacturers with a 0 user base. So I'm not sure how many Apple fanboys would throw away their Apple phone and buy a Google phone. They also have issues with scales of economy, because Google's not a hardware company, and most of their hardware ventures haven't gone anywhere. Qualcomm, which is a big chip manufacturer, won't sell Google their processors in their modular format because they can't get guaranteed volumes. The reason why your iPhone is so sexy is because of a particular form factor and high volume manufacturing and the distribution to the sex appeal of iPhone. So that's why they can get manufacturers giving them good prices to build low cost phones. This thing will cost several $1,000s once it hits market. Nexpaq doesn't compete with phone makers. We complement them. We create a phone case. It takes us 2 weeks to design and tool up a new phone case for a new phone that gets released to market. These other ones, Pebble, Jawbone, Tencent, Nest, Fitbit, they all have one thing in common. They're single platforms that don't share data. Everyone is trying to create their own hub of IoT devices. And this is not going to be sustainable going forward. I can imagine in 5 years from now how many smartwatches there are going to be. If you're a developer, where would you want to spend your time building an app for a particular smartwatch? Clearly Apple's in probably front and center, Samsung and so forth. But at the end of the day, with technology and with most things, there's either a duopoly or a monopoly of technology, like Intel, AMD, that sort of stuff. We want to be those guys because we want to have nexpaq is open to everyone, on the gateway side or on the module side. This is a quick video clip of sort of how we're growing our development community. We've got a strategy to work with incubators, doing hackathons and getting into universities. Incubators is a big one. That's a fairly new. This is an incubator of sorts, correct? Yeah. So there's a lot of incubators popping around the world, and they're all trying to do a lot of hardware. So we're creating what we're calling nexpaq labs within incubators. So we're creating that network. And let's have a look at.
And we are really proud to announce the opening of the IOX nexpaq lab.
Our team is already designing Dora for nexpaq.
We are very interested in the various modular phone concepts like nexpaq, like iron.
We are creating our mechatronic design course on nexpaq.
Hey guys, you gotta join me at the nexpaq hackathon, Melbourne 2015.
They're sort of the different examples of different channel partners that we use to grow our network. Now let's talk about the development kit, because that's, I guess, what you're here for. From day one, our modulus operandi was to build a platform and to build a development kit to create these gadgets. To a point where we did this first, and then our 12 modules that was released on Kickstarter and on our web shop was built based on this platform, just to show that we could do it. A high level sort of overview of the development architecture is as follows. This is the main sort of development board, which is essentially your Arduino. It's all the electronics in one of our phone cases, but expanded out. It's not easy to see, but there's 6 slots for the modules here. This is what we call our developer module. It's got a MSP chip in it. Has anyone used MSP chips before? No? Okay. That has all the common hardware interfaces that you could possibly want, such as I2C, UART, A2D, PWM, that sort of stuff. All the firmware libraries are already built into this chip that we've coded. So essentially what you need to do for a POC standpoint is your sensor, which in this case that's a breathalyzer, or an Arduino project or a Raspberry Pi project, you just hook up with wires to these interface pads on this developer board. And through this entire communication stack, Bluetooth to your phone, you will see your sensor value appear on your phone immediately. So we abstract away all the need for any low-level drivers, as long as you've hooked up the right output to the right input on our development board. So this is really trying to abstract away any sort of nitty-gritty grunt work when it comes to engineering, and allow people, or students, or incubators to focus on the creative aspects of product design, rather than the low-level grunt work. This is our development kit. It's actually here, so I can show you guys live in a second. We offer a whole bunch of sensors, modules, and passive components, breadboards and connecting wires, and obviously the development board. From there, you from the development, so the MSC development module, it looks like this. And that's actually if I could, maybe I can pass this around so you guys can get a closer look at it. There you go. So that's the IC. These are the standard hardware interfaces around the edge, and we've got these prickly pins around it where you can hook up your wires to, and each pin has 3 functions, and most of them have 3 functions. There are 3 functions. There's a default function, second function, and third function. You can use them as general purpose I/O, or you can use them for their special values such as PWM or A/D and so forth. The awesome thing about this is that you don't actually need to reconfigure a pin to another function. So you don't have to do your pin select codes, you don't have to do your binary shifts or anything like that to pick what function you want that pin to be. We do that all via software. So once you Bluetooth to the development kit and you've got your MSP module plugged in with your wires hanging out of it, you can in real time go into it, look at what's happening with your ADC port, change your various pins to GPIO in or out, send commands or set PWM values, or set SPI, UART commands and so forth. There's no programming involved in doing this, but it's very quick to understand, does your sensor actually work on our platform? If you're a little bit more hardcore and you don't actually want to use our libraries because you want to control interrupts, you want to control frequencies of the A/D and so forth, you can use what we call our Breakup Module, which doesn't have any processor, it doesn't have a CPU, it's literally just our connector going into 2 sides of the board. We have a USB connector, a micro USB on the end. Actually, let's pass that one down as well. These little things are make it very hard to find. So, nope. Here we go. That's Breakup Module. Then, so that's sort of phase 1. Once you've done within days, hopefully, your POC of your sensor or your gadget on our platform, then you move to phase 2, which is actually trying to miniaturize it or put it into this form factor. The 12 modules that we've built on our platform are fully open source, so you can reference them to see how we've hooked up ISOC or how we've hooked up USB or our A/D. From there, you also move into the mechanical side, which is standardized sizes. So this is probably the single most largest cost for any gadget. So if you take, for example, that blood sugar module, that would have cost $200,000 to tool up all those components. And that's similar sort of money that we need to spend with this sort of stuff as well. But because it's standardized or recycled, you can use a tool over and over again for different modules. The only thing that you possibly need to change is this top plate, which is essentially a $10,000 exercise. We've got 2 tutorials sort of to get you guys going. Digital signals, which is using a breadboard, hooking up to the various I/O on the MSP chip. You learn how to accept the digital input, on-off switch, and turning on a light. Very basic. But it gets you familiar with sort of the upstream, downstream communication between the phone and the hardware. The second tutorial is all about analog and PWM signals. The potentiometer, which is part of the kit, brings in an analog value which you can adjust, and then you use that to set a PWM value to adjust the brightness of the light. So that's all well and good, but how does that translate to democratization of hardware? So we spent a lot of time trying to work at the business model for developers. The interesting, we've sort of covered this side. The interesting part is, well, how do you actually go to market with this? Clearly the hardware app store is where you want the module to be published. Crowdfunding is also a big thing nowadays. Essentially, if you need to crowdfund your specialized tooling for a top plate to raise $10,000, is not beyond the realms of possibility if your module is particularly popular for the vertical that you're targeting. And also we have a lot of press partners, newsletters and that sort of stuff that we've built up over time. The sales process is also quite complicated in that there's a lot of people that are part of the supply chain for a device, obviously manufacturers, distributors and so forth. We, as in nexpaq, will control that entire supply chain side to abstract that away from a developer in the initial period. But that's simply because we want to ensure quality is up there. but eventually we will open the business model where inventorying and manufacturing through your own preferred partners, which is more in the case of large companies trying to create their own gadgets. That business model will open up shortly. Is there any questions?
Can you just talk a little bit, maybe I missed it, about how you do the programming part on the phone?
Yeah. So the programming, I didn't actually talk about the programming at all, but the source code for all of this is open.
Right.
So how we've done this in terms of what the function calls and the libraries that we use is open for you guys to either modify or just use as is.
So do you write a specific app for each piece of hardware that you're, like you had some breadboard examples there, right?
Yes.
So do you have to write an app to do that exercise, or is it just
No, you can
manipulating the phone?
You can use. It might be good if I can show you how it works.
Yeah, sure.
Yeah. Whilst I set this up, is there any further questions? I'm sort of done with my main part of the presentation. I can talk a lot about who we are and money side and our pain in Kickstarter and PR, but I don't know if you guys are interested in that sort of stuff.
Does anyone have questions for Jason? Sean?
So where is it at in terms of, you talked about partners you've got before and you're out and about, but in terms of, is it mostly in research labs and things like that until?
So I guess there's a chicken and egg problem, which is buyers of the product and then and developers of the platform. So we're addressing both of them. We use Kickstarter as our sort of first toe in the water to see do people actually want to buy this stuff. Our result on Kickstarter wasn't as high as we wanted it to be honest. But it was more because people didn't quite understand what they were buying. The early adopters couldn't understand, oh, this is a pretty cool thing. But would they actually use it for their lifestyle with the modules that we were offering in the starter kit, which was a triple battery, a button, a super light, and I think a temperature sensor. So the utility of those modules for someone to buy is not quite there, and the people who did buy were more just interested. So what we did do, what was successful was that we got 30,000 emails in that process, which is almost more valuable. We had a lot of correspondence saying, we're very interested, but we want to see it in our hands before we buy it, and we want to see more interesting modules that are suitable for us before we do that. And our big thing was that we need to get our development community going. So we've been flying around the planet setting up these incubators. So we've got Skolkovo in Russia, Startplatz in Germany, I don't know if you've heard of these guys, Hardware Club in Paris, Cocoon in Hong Kong, Hubber in Thailand, and a couple others can't recall. But the idea is that we incubate these developers to go through. We're doing a thing with Melbourne University. I don't know if I should be saying that.
No, that's fine. We're all friends.
Okay. Yeah. So one of their mechatronics 4C design subject is going to be based on nexpaq. So they're essentially throwing away their Arduinos and putting this in there. That's 60 odd students starting in about 2 weeks. The hackathon, which is this thing, which your dean has kindly allowed me to put your logo all over, is about a 3-day event. Everyone gets together. We have a whole bunch of mentors. We have nexpaq staff flown over here, and we hack several projects. So if any of you guys want to join, feel free to. It'd be great if you could come on as a mentor and drive a particular team, because we find that Aussie students are generally quite conservative with their own ability. But if they could go in and see a mentor and say, this mentor wants to do this particular hack, they'll say, I want to join that hack. And then they're a lot more willing to join you. So I don't know if I answered your question.
Yeah, I get a bit.
Sort of, yeah.
Do you have any particular contexts or kind of applications that you think might be the things that might open it up? Like I think medical off
Correct.
that.
Yes. So we've got a company out of Asia that's doing they're doing the blood sugar reader, and their thing is that we want to get this into India because it's 25% of the population is diabetic. There's 250 million people. Their thing is that if we can offer a cheap module into a market that seed the market with this stuff, and then they obviously distribute the strips because you still need to give them the strips. Then it's like a third world country beta. When you're talking about these expensive gadgets, you're talking about these cheap modules. And with these cases being a lot cheaper than a phone, you can turn a $100 Chinese phone into a full functioning IoT device, as opposed to a $1,000 Apple into a full functioning. So if the sex appeal of your phone starts moving away from the form factor of the phone and the ecosystem of the software and towards hardware, then it almost doesn't matter what sort of hardware you have on your phone. So there's a lot of different angles that we're all exploring. But again, as a company, we're trying not to do any sort of product development work. We're really focused on this platform, and we want other people to do even the gateway side, such as phone cases. We did a few Q&A sessions where we got some really bizarre questions, like, can I put it in my skateboard? My answer to that was, yeah, you're a skateboard manufacturer. If you are, please contact me, because I mean, like, whether or not you're going to ride around and measure air pollution, I don't know what the utility is of that. But there's a lot of really weird people in the world, so there's a market for everyone. I plugged this dev board in. What I'll do is, I don't know if you can't be able to see this. I've got some live examples here as well, which will be cool for me to show you, maybe afterwards.
So maybe just while you're doing that, another question is, so you showed a lot of those custom devices like the Nest and Fitbit and all those kinds of things earlier. I guess one big difference between that and your device is that they're designed specifically for that purpose. Right. So you're trying to sort of generify hardware to the point where there's no design in the hardware that's exclusive to what it does. It all just fits, it's replaceable.
We're trying to offer options on how far along the design process you want to take it. Yeah. We give them a massive leg up with the form factor and libraries.
So something like Nest, I mean, that was really popular in the beginning because it was a beautifully designed device. It just did what it was supposed to do, and it did it really well. So I guess the question about this is that enough to get rid of that thing about designing something
water thing or some sort of bridge. And it's got they use light sensing to determine what the level of is in your thing. Yes. So they're using our RESTful API on their app to get their data into our ecosystem. So that's an example of someone else's hardware but on this ecosystem, because they want to know drinking lemonade and diabetes, what is the correlation between the two? Where should our target market be? Give us all this diabetic data. Can we pair the two and offer higher level insights? That sort of stuff. So I guess what we're trying to be is an open platform for both hardware and software at any point in the value chain, from zero to almost full product where you need to be part of an ecosystem. So what I've done is I've Bluetoothed to this gateway. I can plug in like a light sensor that comes up on the screen. I can turn it on. It's just to show that it sort of works end-to-end communication-wise. This is a temperature sensor that we put in the kit. And that will, so there's ambient humidity, surface temperature, and ambient temperature. So if I sort of cover if you look at them, it's extremely small, you guys can't see this, right?
You just have to trust him.
So if I cover the sensor, then that 18 will go up to, so it's gone to 27.
Yeah.
If I take it off, it should come back down, the middle number. Yeah. If I could grab that MSP chip back.
Oh, yeah. Someone's pinched it.
Plug that in. Something happened with I got no sound.
Is that the right one?
Oh, there we go. this demo is not going to much to plan. Oh, hang on, I'm plugging it backwards. That's right. Okay, so that's one thing we've got to solve. You only can plug the module in a certain way. So you plug it backwards, it resets the board. I just figured that out. So I've plugged in the MSP module. It comes up as an unknown. I can go in there. It also has general purpose I/O in, so they're reading lows. If I change this to like an ADC, because we know that pin can be an ADC, that's the ADC value, but it's clearly just floating around because nothing's connected to it. Pick something like a PWM, you can set the duty cycle of the pulse width to 0 to 100%. You can change things like that, can be an out, so you can set a high-low command and obviously trigger the voltage change on the pin. So this is sort of hooking up, if we look at what's in the kit, you can hook up a buzzer, some LEDs, an ultrasonic sensor, control some relays. You can quickly work out if your thing is working via this sort of app, just by manipulating the I/O. But clearly going beyond that is, well, let's just get the libraries from this app, embed it into your own, and make your sensor work in a more interesting way.
So how do you see it going from, you do something on the development board, how do you get it into being a module in the case?
This is, what we're saying is a POC that you can do within days.
Yeah.
Once you're confident that it works, and it could be an entire Arduino hooked up to this, if you've got a pre-existing project, then you move into the next stage, which is getting it to this form factor. And unfortunately, that can't be magic. You still have to do some design work. But I mean, the common hardware interface is already done with these 12 modules, so you know how we've hooked up. If you want to use the MSP chip, which is very, very cheap from TI, you can see how we've hooked up various I/O and how we did the layout. So you can't avoid that. Once you do that, then you can move into sort of the mechanical side. So there are elements of this hardware.
Does anyone have any other questions? Or?
I was going to say, is this something that you reckon in the future that you'd be licensing out to phone makers so they can instead of foregoing the case completely, like being able to actually plug those modules into a phone?
Yes, so we've been in contact with Samsung. They're really struggling. They're trying to differentiate the next generation phone because they're losing a lot of market share. They were telling us the gaps in their designs where they could possibly put a module, a nexpaq connector in. We don't know where that's going to end up, but what we're saying is that the gateway side, which is what you're talking about, is also open. So there's a module development kit where you can create your modules, but you've got your gateway side where you can work how to put connectors into your product. We just don't talk about the gateway side because we don't want to confuse the market. Already the market's extremely confused on this sort of stuff as well. Like imagine me doing an elevator pitch for all this within 30 seconds. It's just extremely difficult. And that was a problem we had with Kickstarter as well. You know, we weren't selling a microwave oven where it was very clear what you're buying. This was a bit more of a, sort of, you need to sort of make several leaps in your head. What I can do though is show you one of these prototype cases. Or it might be easy if I just show you
I was going to say, if I can just add on, I don't know if anyone sort of remembers it, but like the Game Boy camera and like the Game Boy printer, like those sort of things. Like I remember as a kid, like I absolutely loved the Game Boy camera. Like not everyone had it, but the people that did was like amazing because you could play games and you could also chuck in this other thing, and you almost wish that it did have more slots so you could put in other things too.
Yeah, I do remember that. I had the AA battery, 4 of them on this grey Game Boy. Now I wish I had that. I sold my SNES recently. The stupidest thing, for $15 at a garage sale, only because I wanted to be part of the garage sale. Anyway.
You sold a piece of history for 15.
Oh, stupid.
Greatest game console ever.
You'll buy it back.
Yeah, for about $500.
I've had 2 SNESes at home.
I think this one's a good
Hey
demo.
guys, this is nexpaq and here are our newest samples. You will see our newest iPhone 6 case where I already plugged in a few modules. I can open the case on the top side, use my normal iPhone 6, plug it into this case, close the case, and I'm ready to go. When I open the app, I can directly connect to this device and see all the modules which I have on the back side, which are in the moment a laser pointer. So when I slide it in, I can use it to make a presentation or to play with my cat or for something else. You will see a flashlight where I can go inside the app, can switch it on and off, or can change the color, sync it with my camera to make better pictures in the dark. You will see a shortcut button. When I press it on the other side, you will see that the icon is changing, and I can assign it with any function like order pizza or call my mom or do something else. Right now when I press this button, the flashlight is going on the other side off. You will see also a loudspeaker which is giving my phone more audio power, plus a temperature and humidity sensor which is showing me the ambient temperature, the surface, the ambient humidity, the surface temperature and the ambient temperature. If I, for example, put my phone above my coffee, you will see that the middle number is changing to above 30 degrees. If I take it away, it's going down to 20 something. You see here our S5 case, which is working the same way. So when I open the app, I can directly go inside and see all the applications which I have on the back side, for example, like the battery. If I want to use it, then I can plug it in. If not, I can plug in another module. And you will see the alcohol sensor. I use V-stick and air quality sensor. For the alcohol sensor, you see me want a number of 0. If I take now a bottle with alcohol, or if I'm drunken, then I can actually directly blow on this module, and you will see that the number is changing. Now to level 4, so this means it will mean I'm seriously drunken. And you get a nice UI where you can click inside, see a nice chart and the different limitations for different states and countries. If you don't want to use a case or you are using one of the phones which we are not supporting, you can go with one of our battery packs, which is giving you exactly the same functions. I can plug in the same modules and access them from exactly the same app. Once you have an nexpaq, you can not only use the modules, but also go into a cloud section where you can access all your data, analyze it and visualize it, plus also in a hardware app store where you can not only buy modules from nexpaq, but also from third-party developers which are working on additional modules like cameras, 3D cameras, glucose meter and others.
So that's just a bit of a live demo. I don't have anything else to say, but
is the idea to keep it Bluetooth, or do you or case potentially plug into Lightning or
yeah? So they actually all plug into Lightning and USB. So the white sample somewhere.
It's been floating around.
No, that's okay. That one was USB only.
Yeah, sorry, there it is.
They all have these connectors.
Yeah.
The problem that we had, so the Bluetooth sort of was a bit of a cool thing that we added that was actually a solution to a problem. We found that once you had your phone plugged into USB, the USB was always active and was drawing power even if you weren't using it. And we're working out ways where we could put it to sleep, but then there was no way you can wake it back up if you disconnect the USB, because that's the only form of communication. The best way is via Bluetooth in terms of power consumption. It also allows you to be able to connect to your nexpaq phone when it's not actually connected to the phone. But all the high speed stuff is via Bluetooth and Lightning. So every module has SPI and USB, so that's why you can, and it's standardized for iOS and Android. There's an 8-layer PCB running throughout the case with all the tracks. In the iOS version, there's actually an embedded Linux OS running on a chip, which serves all the modules and then turns it all into Lightning so that iPhone only sees one sort of port of communication. But with Android, it's very easy to just multiplex USB. So I'm just sort of showing, if you can see that, as I sort of plug them in, they rock up on the screen. So this is why
Everyone just hold up your phone and everyone can see.
Are they there?
You got 5 to 6.
5.
Which one are those?
Button.
Oh, this one. Right, so one of
Yeah,
them.
they're all on there now.
Okay,
Yeah.
So this is actually our previous connector design, which we had a lot of trouble with. We went from these massive connectors, which were really reliable, but we thought were too big, to these really small ones, which weren't reliable at all. Now we've got this one in the middle, which is just right, but it's got the right sort of tolerances on it. And we're going to mass production with that. Our manufacturing partner is Foxconn, so you guys know Foxconn, right? So they've helped us a lot through this entire process of materials for the final production, all the tests. You got to see Foxconn City. If you're ever in China, let me know. I can take you there. They've got the one in Shenzhen employs 300,000 people.
300,000?
300,000 people in one place. They call it Foxconn City. They've got their own hospitals, TV networks, commercial districts, schools. It's all in there. It's absolutely nuts. Like, you can't fathom how many people are there. Foxconn employs 1 million people globally. Well, almost everyone in China. But that was the biggest facility, and you surrender your passport at the gate. It's full on. Yeah. But yeah.
I've got a question about iOS map. And so the sensors only stream data to the app when it's launched, correct?
Correct.
You can't, so for example, you know how you gave the example about the pollution, right?
Yes.
You can't have the app being fed the sensor data in the background unless it's actively running, right?
At the moment, that's correct.
So like, how are you going to deal with that on sort of the iOS side? Because Apple's very limiting with, you know,
multitasking.
Yeah, very limiting.
So apparently a new OS is fully multitasking. Does that answer your question?
No,
but no,
it is.
I mean, Apple is a really difficult set of guys to work with because they really control the ecosystem. So their MFI tests, the getting to their Lightning connector, getting onto the App Store is extremely hard. We're in negotiations with them at the moment because with Android it's very easy. In fact, we use this launcher app, and each module has it's like a plug-in to that app. The actual app could live on the module itself, or it could just be the icon where you plug it in and the icon shows up, so it's instant, and the app downloads in the background through our cloud. With iOS, it's once you have an app on there, you can't really change it, so you can't add plugins and that sort of stuff. And will Apple actually allow us to get nexpaq onto their app store? That's a big question mark, and we're talking about that with them now. Worst comes to worst, we're going to have to launch this in a full browser environment where it might look like an app, but it's actually running within a browser just to get around this Apple issue. But the Apple guys that we're talking to seem to be playing nice, and they're actually thinking about putting some dollars in, so we'll see where that goes. But yeah, at the moment, the answer is no. We've got if I plug in a temperature sensor. If I plug in a temperature sensor, for example, you can hit the button to read the 3 values of temperature, ambient, and so forth. There's also continuous mode where it actually graphs it. But yes, you need the app active to do that. Hopefully that we can change that in the future. Cool.
Question, who's put in funding so far?
So myself and so I look after an investment fund out of Australia. We put in the seed capital for the business. It was the founders. So just in terms of the cap table, the founders put 200,000 US in, and they had some business angels that did another 200,000, and then we put in $1 million US. And now we're raising the next round. We're looking at 5 million. So if anyone has 5 million in their back pocket. So that's sort of where the guys. The great thing about working with these folks, these guys, is that I can tell. I'm sure you can tell from the accent that they're German. They're really good with execution. So every single milestone. So if I show you this. Can you guys see that? Not really. So essentially from 2013 to now, these are the milestones that we've set out for ourselves. I hate this Lenovo computer. It's essentially the money side and the valuation of the company. So this is where sort of our consortium came in, and this is where we are now. and then there's like bigger numbers that way. And also the development of mass manufacturing modules, gateways, it sort of streams down here. And I think it's because they're German, they're so detailed with every little thing. They'll give you 1,000 charts to tell you how much money they're going to spend in the future in 10 months from now. Whereas in Australia, we do budgets just to keep the banks happy, and then we try to, then we talk around the bush when it doesn't happen. These guys,
how accurate are their predictions?
They've been accurate for the last 2 years.
Right.
For the nexpaq has, which is really impressive, and I enjoy working there for that reason alone. Obviously, there's still a lot of risks to navigate, but things are looking positive. Cool.
Anyone else have any questions just to finish off? Sarah?
Just a question on design. So if you everyone obviously gets new phones, and you're bringing out new covers for each different type of phone, but then there surely it is a limit to how many you can actually cover. I like the battery pack idea. I think that's nice because it actually means that you can. It doesn't matter what phone you have.
Yeah.
But surely, is there a kind of flat rate for the price of the covers, and then the rest of it you can just plug it into anyone?
Yeah. So the modules stay the same. The covers. So if you upgrade your phone, you just need to buy a new case, and your old modules will work. In terms of cost, so the biggest problem is tooling for a new case. And when I say problem, I mean cost. It's about 60,000 US per tool per case. So if you look at the economics, we need to sell 1,000 cases of that particular phone for it to be for it to break even.
Can you recycle the previous cases though? So is there if there's mechanics inside the old case that they're not using anymore, could they send them back and get?
So that's even further modularity. Potentially yes, but realistically it's going to be very difficult because every case is, the cameras are put in different spots, and it's actually very if you can open one up, the electronics, which is all along the back spline and down here, and the extra batteries here, is very packed. And part of the reason why our cases are so rigid is because it's an 8-layer board in there. You can't flex too much, otherwise you've got traces sort of breaking into each other.
But there's another question: if you drop it, is everything broken?
So we've done a lot of. So Foxconn's doing the drop testing with us. There's actually in these modules the only way you can. Actually, let me pass this around. The only way you can get them out. These connectors are sort of crap. They're the early ones, but there's like a bit of an aluminium extrusion on the very edge of the module. So we've done a lot of rapid lifestyle testing. So there are 10,000 cycles. It's not just the connector that's holding it in place. There's and you'll see it, there's like a tab. So when you lift it up, it sort of jams against the tab, and you have to lift it up.
Yeah.
So you sort of slide it in from an angle and click it in.
Mm-hmm.
That, that's getting refined now. I think we've fairly settled on it. If you notice with that particular case, some connectors seem very loose, some seem a lot tighter, because the tolerances are slightly off. Even the paint affects the tolerances. These are all CNC parts. They're not injection molded parts. And it's the old connector.
Do you see the phone case as the most important way forward, or the battery? For someone who actually doesn't like carrying their phone around when they don't have to,
You're very rare.
Yeah, I know. The battery pack for me seems much more interesting because there could be the module that when I'm going to go for a run, then there could be an
individual module.
There could be a module in my pocket, or a module that's on my phone or my wrist, and I just get back and I get blink, and then the data is in the ecosystem. To me, that's actually the more compelling thing in a way.
I think different people in different markets have sort of different views on that. Our big thing is that we want to be on a platform that saw the advent of the software app store, which is a smartphone. And because everyone's got one, it's like the common device that everyone has. So it's like the hub of the IoT devices, rather than doing what other people are doing, creating their own hubs with their own sort of central gadget. We want to use the phone, but we don't want to replace the phone, so hence the logical choice was a phone case. But this is very much underway. This home automation version is almost released. This is like the backpack, which is what you'd like strap it to your skateboard or wear it around your neck or however you want to use it. But yeah, we see the ecosystem progressing much beyond cases.
Do you imagine seeing much of a split between the like, it seems likely that modules for like the home dashboard might not actually like things you want to do on the home dashboard might not actually translate to your phone.
Yeah, so this is not connected to your phone at all.
Okay.
So that's a gateway. So it actually has a Wi-Fi module inside the plug section. This is like an LCD screen, so that's sort of your feedback to the person. So the idea is that the gateways, it doesn't have to be tethered to your phone. This is tethered to your home network via Wi-Fi, and you've got your temperature, CO, and your camera there.
Yeah, but I'm more thinking like the individual modules.
Yes.
Would you get into a situation where you have a whole bunch of modules that say only work with the home dashboard and not on the phone? Like, is that going to get difficult to manage?
Possibly. I mean, we have channel partners to do all this, so we're actually not inventing this device, we're helping them. But we've got a home automation company that's doing it, and the reason why we use them is because they've got the route to market. So they'll clearly want to create their ecosystem of modules, which would be probably more suitable for a home automation application. But if they're following our standardized process, then there's nothing stopping someone from plugging it into a phone. The utility on a phone might not be there though.
Yeah. Okay.
I think we've just about run out of time, but maybe just say thank you very much, Jason, for coming out and talking. It's really fascinating.
If you guys are interested, please sign up for the hackathon. It'd be great to see some Monash representatives.
Can we keep this?
Yeah, I've got a whole stack.
Oh, great. Okay. Good.
Wait. Yeah, take